advantage is channel bonding, which is quite common. I'm sure all of you have heard about this. But channel bonding is just simply combining two channels together. We know that in 5 gigahertz, the channel width is 20 megahertz. We know in 2.4 it is 22, but we round it off to 20 megahertz only. This is the channel width of each channel, right? Now, if we combine two channels together, we have approximately 24 channels of non-overlapping channels which we use in 5 gigahertz. So if I combine two, I still have around 12 channels available, right? But in 2.4 gigahertz, we have only 3 channels available to send traffic, correct? That is 1, 6 and 11. If I do channel bonding in this, I effectively have only one channel available to send traffic, and this is not feasible. So channel bonding should not be done on 2.4 gigahertz. Channel bonding should only be done on 5 gigahertz. The advantage is, think of it in a way, if I have a highway of 20 megahertz width, okay, I have some traffic which is going, some cars which are going, some two-wheelers, some heavy traffic, heavy trucks going. Now suddenly, if I double the highway size, will it not become easy for traffic to go? I am just by doubling the bandwidth or doubling channel width, I am effectively doubling the throughput again. Okay, so I am currently doubling the throughput by just increasing or doubling the channel width of the 5 gigahertz channel. Now in .11n, we can go all the way up to only 40 megahertz. Maximum channel width can be 40 megahertz, which means we can only combine two channels together. In .11 AC, we can go all the way up to 80 and then 160 also in wave 2, but we'll talk about .11 AC in the few next videos. But for now, you need to know that maximum channel width in .11n can be 40 megahertz, right? Now this has massively increased the efficiency of Wi-Fi medium, and I would suggest that if it's really needed, only then make it 40 megahertz. By the way, this setting of changing the channel width to 40 is configurable on the AP. You can configure it and then make sure your AP, anyway, once you configure it, it should follow 40 megahertz of channel width. But in a network which is, highly crowded, I would not want to make it 40 megahertz. If I have a huge network of multiple APs running, and in that scenario, I would want as many non-overlapping channels as possible. So 12 may not suffice for me. I would want around 2022 channels for me available which are non-overlapping. So in a good deployed network, you need not even go to 20 megahertz. It's just that if you have less clients on an AP and if you want higher throughput, you can go and make it 40 megahertz. But in most deployments, I would stick to 20. I would not change it to 40 megahertz.